So frequently we make reference to the intrinsic value of the option as opposed to the time value of the option. When we refer to the time value, we're referring to the Black-Scholes value if it's a European option. But the intrinsic value of the option is the value of the option on the last day, the option just as the option expires. So if we were to estimate the value of a call, it's the difference between the terminal value of the stock and the exercise price. For the put option, where you have to write the sell, it's the difference, it's the maximum of K minus S. So as the value of the option, as the value of the underlying asset falls, the put value becomes more valuable. We're going to set up here in Python. We initiate the stock price as being 100, and then we generate a series of stock prices going between 50 and 150 in steps of 0.01. So a 1 cent increase sequentially. K is locked here at 100. If we run, so if we take eyeball what S is, starting at 50, $50 1 cent, $50 2 cent, and then the last three values going up to 149.99 to 150. Okay, so to apply this valuation, right, take using NumPy. So we've imported NumPy here, and we then invoke the maximum. So we pick the larger of either 0 or S minus K, meaning we remove the negative values in the range. And likewise for the put, just taking the positive values, never inferior to the 0. And then map out the value of the option, the intrinsic value of the call would appear like this, and the intrinsic value of the put would appear like this. In each instance, we're using matplotlib, and you can see the title of the graph we've put in using PLT title. So the key libraries here were NumPy and matplotlib. The main mathematical operator is we take the maximum of S minus K or K minus S, and you can see here we generate the value of the intrinsic value of the call and put. If we had changed the step size to be a larger step, so for instance, if we had have went 10, you notice that there wouldn't be enough granularity in the option range. So if we try to graph that, you could see that it doesn't really work as well. So typically, I think we would have to start from refresh the series from scratch. But typically, we would find that we would get a certain kind of kinkness here in the graph. And so it's advisable to use the smaller step size. To see that in Excel, I've left a video clip above here, right? Just here, you can, I'll share the link in the video clip underneath, how we would do this in Excel and how we would observe the difference between the intrinsic value and the time value of the option using Black-Scholes.